All right. Hello. Nice to meet you. My name is Amit Rand, and I'm with Neha Mali, and today we'll be presenting PaperLeaf. PaperLeaf is our final project for software construction. We are group 15. So, what is PaperLeaf? To put it simply, PaperLeaf is a full stack web application which takes in your handwritten mathematical work, whether it's proof, a simple equation, anything you want, and converts it into latex. Now, why Paperleaf? Where is Paperleaf coming from? If you didn't know here, a lot of upper div math courses require homework to be submitted in LaTeX. Personally, I'm a very big fan of LaTeX, but after discussing with friends and peers, I discovered that not many people are actually that into using LaTeX. I did a quick search, and what I found is that there really isn't a simple, easy, intuitive solution to converting handwritten equations into LaTeX. And this is a problem because students who prefer to not work in LaTeX will do their work by hand. And after that, they'll spend a good amount of hours just transcribing their work into LaTeX. So Paperleaf offers a very simple solution where you can just upload an image of your work and then you'll be able to simply copy the translated LaTeX conversion. The main goal here is for us to help LaTeX users save time so that they're able to invest their efforts into things that are more valuable and constructive than simple LaTeX transcription. So just to dive into our tech stack, our front end is built on Next.js, which is our web framework. We use React and Tailwind CSS along with some traditional CSS to do most of our front end and styling. For our back end, we're using Flask. For our backend server. We're using that in combination with Postgres, which is being hosted on Neon, and Drizzle ORM, which is our adapter for the machine learning, the model, the convolutional neural network that was developed using TensorFlow and Keras. For authentication, we're using NextAuth, which is a open source authentication framework that works that's compatible with Next.js. And yeah, we've just been developing locally on Node and Python environments. So we've been working in a virtual environment and just overall managing our dependencies in both environments. So now I'll dive into the key features of our web app. So first and foremost, there's obviously the uploading of images and converting them into LaTeX. So to show you guys and give you an idea of how this actually works, let me just pull up the web app. All right. So we're just going to get everything running, everything good to go. And now we'll open it up. So this is our landing page, just to give you guys an idea. One sec. So you come in, you're greeted with this very user-friendly, very nice landing page where you can easily log in to access the user dashboard. If you aren't logged in, you won't be able to access pages such as home or dashboard, and you will just be locked out as those are protected routes. Our front end is styled dynamically so that you will be able to easily navigate and interact with our website in a very user-friendly manner. So let's authenticate now. So as you see now that I'm authenticated, I can actually log in. I can actually use our services. So here's the service I was referring to, the uploading and translation of handwritten images into LaTeX. So let me just pull up an image real quick. Nope, one second. So here, I'm uploading this image. As you can see, we have this entire image uploaded here for preview. If I decide maybe this isn't the image I want to go with, I can delete it. I can choose to select a different image. So maybe I want to go with this image of the alpha sign, and I like this image a lot more. So I'm going to go ahead with it now. So when I submit, what you'll actually see happens is a few things. First of all, We're still shown the image over here. And next off, we're given our prediction from the model. While the model, something is a bit messed up with it, so it is outputting gibberish right now. All the functions of the web app are still together, they're still working. So let's say I just want to make a quick change here and I want to add a backward slash to this n. As you see, the user is easily able to work in this text editor, and from there they're able to just copy the text. If you want to see, you can just paste it now. It's quickly copied to your keyboard, whatever it is. Let's say we want to actually go back and check out a different image. We can also now try div, see what happens. And now we see that we actually run into an error where the model isn't able to detect the symbol in the image. So as you can see, our web app is actually built to handle these errors. And this component is built very dynamically so that the user doesn't actually encounter a server error. Um, and yeah, I mean, it's pretty straightforward from there. So I'll go into the next feature. Sorry, real quick. So, oh, the next feature is pretty much a user upload history dashboard. So every upload you make will automatically just get registered here, just for your reference, so that you can check it out. We store the user's metadata and of the image, and we also store the LaTeX conversion. So it's pretty user friendly. You'll just be able to check it out right now. So as we saw, we uploaded our first image in, and we got the translation of n. So we're going to upload a few more images next to display the next feature. So 1 second. So the way that our app also works is that we want to gain traction by encouraging users to refer their friends. So at a certain point, you'll see that um, you're actually limited to the amount of uploads you're able to get. Um, so here, let's just check the dashboard's updating. For example, it is a prediction, even though it is gibberish. But as you can see, before we were uploading single images and now we're uploading actual words. So in the actual backend, there's a very cool segmentation going on that pretty much takes in the image and on basis of contours breaks it down. So the initial image, just to pull it up again, has a lot of components, and from there it's segmented. It's pre-processed using a variety of changes, such as mapping the colors to gray and then applying a Gaussian filter. And there are a few other data image pre-processing techniques applied to really make the contours pop. And then from there, a bounding box is applied. Um, Smaller elements are filtered out just due to the nature of the logic picking up random noise. But overall, it's pretty successful in segmenting most of the key components of the LaTeX. And then from there, it is parsed into the model one at a time and then concatenated together to give you your output. Now, while the output is gibberish, we do know through the backend logic and this folder here that stores the temporary segmented images that this is working. Um, so at that point, the image is pretty much just constrained to the actual model. So we're just gonna keep going till we actually hit 10 images. And the reason we're gonna do this is to show you what happens once you pass the deadline. Once you pass the limit that's actually set. Let's check how many we're at real quick. We're at 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 second. Oh, and we get limited. So as you can see here, what happens is that at a certain point, you're actually limited to the amount of times you can use our service. So if I want to continue, what I will have to do now is to enter the email of a friend. So I'm actually going to swap over to a different account to show that this feature works. And I will let Neha take it away from here.
Okay, so from here on out, our the way our referral service works is it will first take the email address that you've submitted, and then it will basically try to pull that email address from the existing user database that we have. And if it's unsuccessful, that means that user does not exist. And then it also takes a look at whether you have referred this email address already, and by looking at the referrals table instead. And then it would also, our referral system is equipped to give you an error if you've already referred this person, even if they haven't accepted that referral yet. So um, looking at the error handling just now, the first time that Amit clicked continue, he got a random code, and that's what we're going to use to track the referrals. And the second time he clicked continue, it said email referral request already sent, meaning that this has already been inserted into the referrals database. And rather than seeing a actual server error, our system is equipped to handle that error by just giving you a very user-friendly statement saying you've already sent the referral request. So now Amit is going to go to the Neon database, and then you can open up the referrals table to see that you've inserted a referral email that is directly tied to your user ID. And it says the descriptor is one because you're the person referring that email, and your referral status is automatically set to false, meaning that person has not created an account yet, has not inserted your referral code yet. So now Amit has logged into the second account, that the one that has been referred, and he will click have a code. There he will copy paste the code, and then our system will validate the code. And now that it says success, he can go back to his original account. And seeing that he's now able to put in additional images, we can check the dashboard just to verify that. Yeah, now that the referral status has been set to true, which essentially means that the person you've referred has inputted that code and has therefore successfully been referred, you can go back to your original account and you can continue uploading images.
Yeah, thank you, Neha. And then just to add on to that, so images and LaTeX translation are stored in our database. On top of, in combination with next auth, a few more things are stored. So first of all, we have the actual users. As you can see, the two users we just used. Additionally, we have the OAuth through our third-party provider, Google. And finally, on top of that, we also store the session. Um, these are just automatically propagated into our database in conjunction with next auth and our adapter. Um, and then those are our three key features. And I will just bring this to the next step slide. So just to give some context, we didn't get around to sending out an email to users, which was an aspect we did want to implement. So that is on our to-do list for our next steps. So instead of just copy pasting a code, they would be able to actually send the code in an email to the user. On top of that, as we talked about, the model currently got messed up. It outputs gibberish, and due to finals and a mix of other stuff, we just haven't been able to run a new one. Um, Initially, we were actually planning on using a transformer, and the CNN was a backup model. But what happened was we found out we weren't able to get enough computational power to successfully run the transformer. And then we got stuck with the CNN model, and we built a segmentation logic. And then from there, the CNN model got messed up, and now we're at a point where the accuracy or the performance of the model doesn't matter. So in order to submit it for the project, the other features do. So just due to prioritization, we weren't able to get it working at the state we wanted to, but that'll be in our next steps. Additionally, right now, we only have image functionality. We want to eventually expand to support files and multiple image and file uploads. And finally, we want to deploy our actual site. Once these are built out, and we'll be deploying the front end on Vercel and the back end on AWS, and hopefully containerizing with Docker. And overall, it's been a very great experience. We've learned a lot. Um, I think we really pulled through together at the end, and our project came together very nicely. It's very user friendly, very easy to use. It has all the key functionalities necessary to make this web app work. And after we get the model up and working, I think it'll be a great product. So yeah, thank you so much. And yeah.